In this video, I'll be talking about the projectile motion where an object is launched from ground. The projectile is an object which is thrown into the space. It could be a ball, it could be a stone, it could be a missile, it could be a bullet. So let's talk about the motion of the projectile. So let's say you have let me draw first the axis. This is the vertical axis and this is the horizontal axis. All right, so this is the x-axis here. This is x-axis and this is y-axis, and you have an object, a ball, which is projected from this origin at an angle theta. So this particle is launched at an angle theta from the ground, and let's assume the velocity of the particle is v0. So the first thing we do in order to solve this kind of problem is to resolve this velocity into two components. This component, the first component is, we call the horizontal component v0x, and this will be equal to v0 cosine theta. And then we have another component, this vertical component, and this vertical component is v0 sine theta. So look at this picture here now. So along the x-axis, along this axis, there is no any force acting on it. But along the y-axis, along this axis, there is a force, and the force is downward. The force is always downward. This force is due to the gravity. The earth is pulling it downwards. So as there's a force acting on the vertical motion, the velocity, this velocity will start decreasing. And when it reaches to the peak, then its velocity will be 0. But the horizontal velocity, this velocity, will not be affected at all because there is no any force acting on it. So as a result, what will happen is the path of the object will be a parabola path like this. This is a parabola path. And if you look at any point, let's say this point, the horizontal velocity will be exactly the same. It will be unaffected because the gravity is acting only in the vertical motion. So at this point, the horizontal velocity will be exactly v0 cosine theta. It won't change, and the vertical velocity might change. So I'm just calling it as a vy. Now let's take a look at this point. At this point, the horizontal velocity would be v0 cosine theta, and the vertical velocity will be vy, which is a variable. Okay, so you see at all points, it doesn't matter where, at all points the horizontal velocity is exactly the same, but the vertical velocity changing. The vertical velocity at this point will keep decreasing, and when it reaches to the peak, at that point the vertical velocity will be exactly equal to 0. And the horizontal velocity at this point will still be v0 cosine theta. Right? So what we're going to do now, we'll be now calculating the vertical height. When I say the vertical height, this height from the peak to the ground, this is called the vertical height or the maximum height, which is denoted by h. and the distance which the projectile has traveled from ground to ground, this is called the horizontal range. Horizontal range, and we denote it by R. So let's calculate all the math now. Just focus on the math part. So before we're going to do that, here I'm writing few important things. This is the acceleration along the x-axis, and as I mentioned, as there is no force along the x-axis, it would be 0. That means the velocity along the x-axis is constant. It doesn't change. And along the y-axis, the acceleration is acceleration due to the gravity. That means the velocity is a variable. It's a variable. So now let's calculate the maximum height. How do you calculate this maximum height? We're going to use the kinematic equations. This equation, v squared is v naught square plus 2gh. So this is a formula here. Now in order to calculate this height, we'll be focusing along the vertical motion or along y-axis. So in order to solve this kind of problems, what we're going to do, we're going to solve this problem thinking as two independent sets of motion. The one motion is along the x-axis and the other motion is along the y-axis. So just think about the two motions. So here I'm talking only about the y-axis. So this velocity here is the final velocity, or when it reaches to the peak. And we know that when it reaches to the peak at this point, the final velocity is 0. So this velocity is 0. And v0, this velocity is the initial vertical velocity. And the initial vertical velocity is this velocity, is the initial vertical velocity. Then I can write down as v sine theta, and we have a square, so a square. As a particle is going upwards, here the particle is going upwards, so the velocity is decreasing. That means you have a negative acceleration. So just write down 2g, and when it reaches to the peak, we call that height as h. And from this, we can solve the vertical height as v naught square sine square theta divided by 2h. This is the formula for calculating the vertical height. Or we can also write down this equation as a v0y squared divided by 2g. This is the initial vertical velocity. This is the initial vertical velocity. So that's how we calculate the maximum height. So now let's calculate the time it reaches to the peak. How long does it take to reach from this point to this point? That we call the time to reach peak. Okay, so for this one, we're going to use this formula here, V0 plus AT. This is that's just the kinematic equations, and we know now this is the velocity when it reaches to the peak. So this velocity, again, this is for the vertical motion. Let me write down one thing here. This is the time, and here we're talking about the vertical motion. So this velocity is along y-axis, okay, or the vertical motion. At the peak, the vertical velocity is 0. Now this velocity is the initial horizontal velocity, which is v0 sine theta, because we already calculated this is the v0 sine theta. And as the particle is going up, we have the negative acceleration, and this a is g, and you have the time. So you can solve for the time now, and the time will be v0 sine theta divided by g. This is how we calculate the time. This time is time to reach to the peak. Now let's calculate how long does it take to reach to the ground. From this point to this point, this is called the time of flight, or time the object or the particle or the projectile remains in air. The time of flight. The time of flight, so we have calculated the time it takes to reach from the ground to the peak. It takes exactly the same amount of time again to go from the peak to the ground. It's exactly the same amount of time. So time of flight, t, is exactly equal to twice the time it takes to reach to the peak, 2 times t. So we have, then we know that we already have calculated this time here, v0 sine theta over g. So this one would be 2 v0 sine theta over g. This is the time of the flight. Now the last important thing we calculate is the horizontal range. Horizontal range, and you know that we denote it by r. The horizontal range is the distance from ground to ground, the time when you launched and the time when it reaches to the ground. This distance is the horizontal range. In order to calculate that one, we're again going to use the kinematic equation. And this time, and this will be along the x-axis, because our motion in this case is along x-axis. So let's use this equation. In this case, the distance s is the distance which is from this point to this point, and we call that as a range, horizontal range, or we denote it by r. And v0 is the initial horizontal velocity, or this means this velocity. That's the horizontal velocity, which is v0 cosine theta. And this time here, if you see here, this time t is the time of flight, because the time it takes from this point to reach to this point, between these 2 points, is the time of flight. and the time of flight is given by this equation here. So just write down here as a 2 v naught sine theta divided by g. All right, plus half. And now we have an acceleration, half acceleration. Acceleration, there is no acceleration along the x-axis because there is no force acting on it. So this term will be equal to 0 because there is no acceleration along the x-axis. So what you get now r is 2 v naught square sine theta cosine theta divided by g. If you recall from trigonometry, we can simplify this equation as sine 2 theta divided by g. So this is the formula for the horizontal range. Here we have used one formula here. Sine 2 theta is equal to 2 sine theta times cosine theta. I have used this formula and plugged it in this equation. So this is the formula for calculating the horizontal range. Now let's calculate how does the range changes with the angle. So let's say you have a projectile or a bullet or a cannon, and you were sitting right at this point. You're sitting right here, and you had to choose the angle, this angle, and your goal is to reach to the maximum horizontal range, this range here. You have to throw it a maximum possible distance. What angle you have to launch the projectile? Okay, so here our calculation is maximum horizontal range. If you look into this equation, the v naught is constant. V naught is constant, g is constant. So in order for r to be maximum, that is possible only when sine 2 theta is maximum. And the maximum value of sine 2 theta is exactly equal to 1. That's the maximum value of sine 2 theta. That's the maximum value. So the maximum value of theta is when it is equal to 90 degree. So from this equation you can calculate theta, which is equal to 45 degree. So you get the maximum horizontal range at angle 45 degree. So let me draw the variation here now. If you launch the different projectile at the different angles, how does it look like? So if you launch a projectile at 75 degree, let's say this is at 75 degree. Then and we call this as a 60 degree. Let's call this as a 60 degree. This is at 45 degree. Now if I launch it at 30 degree, and I'll explain this one, this is at 30 degree. And this is at 15 degree. This axis is the horizontal distance, and this is the vertical height. So what do you see from this equation? The range, the maximum range is at theta equals to 45 degree. We already have calculated this one. You get the maximum angle theta when it is at 45 degree. And also, if you also look at this equation here, which we already have calculated, the range is equal to v naught square sine 2 theta divided by g. That is the formula for g. And if you plug in your calculator, sine 75 degree is exactly equal to sine 15 degree. That's a sine 15 degree. Or sine 60 degree is equal to sine. If you plug in, let me put my word back a little bit. Okay, because this angle has 2 theta here, 2 theta, so the range would be exactly the same at 60 degree and 30 degree. So at 60 degree and 30 degree r is same. At 75 degree and 15 degree r is same. That means at theta and 90 degree, one is theta, horizontal range r will be exactly same. All right. Okay. Now, so the last thing we'll talk about is the how do you calculate the angle. So when I say the angle, that means what is the angle when it hits the ground, at what angle it hits the ground. So thus we'll be calculating here the angle. All right, so this angle here is the horizontal velocity when it hits the ground. It does not change, it is exactly the same thing. And the vertical velocity when it hits the ground here, it does have vertical velocity at this point. So this is the vertical velocity v0y. And when you launch a projectile, this velocity, this vertical velocity, when it hits the ground is exactly equal to the velocity, the vertical velocity when it was launched. And if you look at this triangle here, this triangle, this is the vertical velocity component and this is the horizontal component. So tangent of theta can be given by the vertical velocity at that time and the horizontal velocity. So that gives you this. So you can calculate the angle theta is exactly equal to the tangent inverse v0y or v0x. So now let's see, you have to calculate what is the angle. At this point, the direction of the projectile is along this way. And you can also calculate this angle theta here. So this angle theta, or let me call this angle as alpha because we already have denoted this angle theta. So this angle alpha here, the alpha is the angle or the direction of the projectile with respect to x-axis at any point. Okay, so how do you calculate this one? We call this as an angle alpha. So in order to calculate the angle alpha, you have to calculate the vertical velocity divided by the horizontal velocity. All you have to do is just calculate the vertical velocity at this point, this vertical velocity, and the horizontal velocity. That's all you need to do, calculate. So I'm continuing here. So the alpha would be simply equal to tangent inverse the vertical velocity divided by the initial horizontal velocity. So that's how do you calculate the angle at any point. Okay, so all you need to know is the vertical velocity and horizontal velocity. So that's it for this video.